Good day, everyone. I welcome you to another episode of Chemistry of Selected Metals and Non-Metal. In this particular video, we'll be dealing with the most abundant element in the universe. The most abundant element on Earth, and that element happens to be oxygen. Oxygen is actually the most abundant element in the Earth crust. We already know that oxygen belongs to group 6 or group 16 in a standard periodic table, and we have other elements in group 16, which is the sulfur, selenium, tellurium, and polonium. So these are the group 16 elements in the periodic table. There's something I want you to take note of. Oxygen has the atomic number of 8, the mass number of 16. So you can say the proton number there is as well 8, the electron number there is 8, while the neutron number of oxygen will be what? 16 minus 8, that will still give us what? 8. So because of this, we believe that the electronic configuration of oxygen is 1s2, 2s2, and then 2p what? 4. So this is the electronic configuration of what? Of the element oxygen. The group 16 element in the periodic table, we call them the chalcogenes. It is called the chalcogenes. This is spelling Chalcogens. Chalcogenes. That is the group 16 element in the periodic table. And they are also called, they usually form us with other elements. And it's not just for oxygen. We also have other elements in that same group that form us with other elements. Like sulfur is a very good example of that. But most cases, we consider group 16 element as chalcogens, an element that form us with other elements, e.g. sulfur. What about the physical properties of oxygen? So oxygen is a diatomic gas. That's why I have O2 here. It is wrong for you to write oxygen as O. So it is best to write oxygen as what? As O2. And oxygen is actually colorless, it is odorless, and a tasteless gas. Oxygen is colorless, is odorless, and a tasteless gas. It is neutral to moist litmus paper. It is slightly soluble in water. It liquefies at minus 183 degrees Celsius. We know oxygen is a gas. So at minus 183 degrees Celsius, it becomes a liquid. And at 225 degrees Celsius, oxygen become what? A solid. So what about the occurrence of oxygen? Oxygen actually occur in two forms. It's either in a free state or in a what? A combined state. So the free state of oxygen, we already know that that's in air. So for oxygen, we have 20.9% by volume of the atmospheric air, of the atmosphere. Let me use that. We have 23% weight of atmospheric oxygen. We have 46.6% of the earth crust. So on the earth crust, oxygen takes about 46.6%, while the other element takes the remaining percent, which is supposed to be 4. Here should be 4, and here should be 34.4 what? Is it 34? No, sorry. Yeah, 54.4 what percent. So other elements in the periodic table are going to take this 54.4%, while oxygen alone is going to take what? 46.6% of the earth crust. And that's why we refer oxygen as the most abundant element on the earth, in the earth what? Crust. So please take note of this. What about the combined state of oxygen? So for the combined form of oxygen, oxygen actually occur as water, that is H2O. And we already know that this H2O here consists of hydrogen and oxygen mainly, or only, let me use that. So this oxygen in water has the oxygen in water, the percentage of oxygen in water is 88.9%. 88.9% of oxygen is present in water. That's to say, oxygen is even more abundant than hydrogen in water itself. So another thing again, oxygen also occur as ozone salt. I mean in a combined form, ozone salt such as ozone sulfate, ozone nitrate, ozone borate, like triazochlorate. Even chlorate, ozone chlorate. Those are ozone form of what? Of oxygen. And we always refer them to as the combined form of what? Of oxygen. Then the next thing I will deal with here is chemical properties of oxygen. Because of the electronic configuration of oxygen, we believe that oxygen is one 2. For the next year, 3, 4, 5, 6, 7, 8. So there is a higher tendency that oxygen can actually accept two electrons to form ionic bonding. Then oxygen as well can as well share electron. For example, we have calcium oxide. This calcium oxide is an ionic bond or electrovalent bond because there is actually a total transfer of electron. Or we have hydrogen, which is water, which is a covalent bond, a polar covalent bond, and it deals with sharing of electron. So if oxygen accepts electron, the kind of bond that will be formed is what? Is electrovalent. While if oxygen share electron, the kind of bond that will be formed is what? Is a covalent what? Bond. So please take note of these two chemical property of oxygen. So what about how oxygen is prepared? Oxygen can be prepared in the laboratory, and oxygen can also be prepared in the industry. So for the laboratory preparation of oxygen, we have the composition of potassium chlorate. So when potassium trichlorate 5 decomposes, you are going to form what? Oxygen. And even hydrogen peroxide, in the decomposition of hydrogen peroxide, you are going to form what? Oxygen. And also the oxidation of hydrogen peroxide, oxygen will as well be what? Be formed. So in the laboratory, oxygen can be formed from the composition of potassium trichlorate 5, can be formed from the composition of hydrogen peroxide, and also the oxidation of hydrogen what? Peroxide. What about the industrial preparation of oxygen? Oxygen can be prepared in the industry using the electrolysis of what? Of water. So in the electrolysis of water, oxygen is produced. We also have fractional distillation of liquid air. Like what I explained in my previous video, when you compress air into a liquid, air is a gas, it's a mixture of gases. So when that air is compressed to a liquid, and then you separate the fraction, get your oxygen, is called fractional distillation of what? Of liquid air. So these are the process of producing or preparing hydrogen in the laboratory and in the what? In the industry. So for the first one, we have the composition of potassium chlorate, we have the composition of hydrogen peroxide, we have the oxidation of hydrogen peroxide, we have electrolysis of water, and we have fractional distillation of what? Of liquid air, whereby you have to convert your air to liquid by compressing the air. So when you compress your air to liquid, if you now remove the other fraction of air, for example, nitrogen, carbon dioxide, and all that, the only thing that will remain is what? Is oxygen. So that's how you prepare your oxygen in the laboratory. There is something they will call oxide. And oxide is referred to as binary compound. These are binary form of oxygen. It means oxygen reacting with another element, just one element. Is either they are covalently bonded together or they are electrovalently bonded together. I mean, it's either they share electron or electron was transferred. So these are the two ways in which oxide can be formed. So if you look at oxide so well, we have different kind of oxide. We have the basic oxide, we have the acidic oxide, we have the neutral oxide, we have the amphoteric, the peroxide, we have other higher oxide, and we as well have what we call sub-oxide, but I won't be explaining that in this video. I repeat, basic, acidic, neutral, amphoteric, peroxide, and what? Other higher oxide. And we also have what we call the sub-oxide. So all these ones I mentioned now, they are different types of what? Of oxide. So how can we differentiate? How can we know that this is a basic oxide, this is an acidic oxide, this is a neutral oxide, and this is amphoteric, peroxide, and others? So let's try the basic oxide. When when a metal, any metal at all, any metal, when which is, let's say, sodium, most especially group 1 and group 2 element, react with oxygen, the product that will be formed is sodium what? Oxide. And this kind of oxide is called basic oxide. So oxide of metal, they are basic oxide. And when this oxide is soluble in water, I repeat, when oxide of metal, when a basic oxide, let me use that because we believe that oxide of metal are basic oxide. So when this basic oxide is soluble in water, it forms what we call what? Alkalis. So this is a base, and this base, when you dissolve this base in water, is going to form what? Alkalis. What I mean by that is that Na2O plus H2O. So at the end of the whole thing, what will be formed is NaOH, sodium hydroxide. So and this sodium hydroxide is referred to as what? Alkalis, because it's a soluble base. Sodium oxide is a base and it's a basic oxide. So sodium oxide is a base, that's why we call it basic oxide. Any basic oxide at all you know is a base. So and if that basic oxide is soluble in water, it is called what? An alkalis. So we have sodium hydroxide as basic oxide, we have sodium oxide as basic oxide, we have calcium hydroxide as what? Basic oxide. And if you dissolve calcium oxide rather in water, it's going to form calcium what? Hydroxide, which is also referred to as an alkalis, because it's a soluble what? Base. Another thing we'll be looking at here is acidic oxide. So for acidic oxide, these are oxide of non-metal. Like what I said, oxide of metal are basic, while oxide of non-metal are acidic. And please take note, a basic oxide, if a basic oxide reacts with a basic oxide, so when this basic oxide reacts with an acid, is going to form salt and what? And water. So when an alkalis, which is a soluble base, react with an acid, is going to form what? Salt and what? And water. So that's why we call the basic what? Oxide. So for acidic oxide, these are oxide of non-metal. For example, if you have carbon plus oxygen, at the end of the day we are going to have what? CO2. Sulfur plus oxygen, we are going to have what? SO2. So oxide of non-metal, they are what? Acidic. Because this is a non-metal, this is a non-metal, so we call them acidic what? Oxide. So why are they acidic oxide? Because this SO2, if we dissolve it in H2O, it's going to give us what? H2SO3. And this H2SO3 is an what? An acid. So and this oxide, when they react, when this acid here reacts with a base, is going to form salt and what? Oxide and water. Or when this basic oxide reacts with what's it called? A base, is going to form what? Salt and what? And water. So please take note of the difference. Oxide of metal, they are basic. Oxide of non-metal, they are what? As acidic. We have neutral oxide. Neutral oxide, they don't behave acidic, they don't behave basic, so they are neutral. An example of they are neutral to litmus paper as well. Let me use that. Example of that, we have water, we have nitrogen one oxide, we have nitrogen 2 oxide. I believe that nitrogen 2 oxide should be among this group. We also have carbon 2 oxide. I'm not sure of this yet, but I think so. So we have water is example. We have N2O nitrous oxide, which is dinitrogen 1 oxide. We have carbon 2 oxide. So these are example of neutral what? Oxide. So they don't behave acidic, they don't behave what? Basic. But we also have other oxide that behave acidic and basic. An example of them, we call them the amphoteric oxide. So any oxide that have a basic property and an acidic property is referred to as what? An amphoteric oxide. An example of them, we have oxide of aluminium. Let's say Al2O3. Oxide of aluminium, zinc oxide. Zinc oxide. Zinc oxide is an example of lead oxide, tin oxide. So these are oxide of what? Of These are amphoteric oxide. So aluminium, zinc, lead, and tin, they are all considered as what? Amphoteric what? Oxide. Then the next one we have there is peroxide. Peroxide is actually referred to as a higher oxide. Peroxide is actually referred to as what? A higher oxide. So when, for example, let's say H2O is a neutral oxide. When the proportion of oxygen is high than the normal amount, if the proportion of oxygen is supposed to be 50 and is that higher than the actual amount, which is 60, we call this what? A peroxide. An example of them, hydrogen peroxide. Barium oxide is supposed to be like this, but you now put to here, it's called barium peroxide. This is Na2O. Look at it here, sodium oxide. If you now put to here, it's now called what? Sodium peroxide, because we have a higher amount of what? Of oxygen. Let's look at the next one. Calcium oxide. Look at calcium oxide here. But if I now put the 2 here, it's now called what? Calcium what? Peroxide. So peroxide is actually a higher, when an oxide have a higher proportion of oxygen, let's say more than the expected amount, The product form is what? Is a peroxide. So what about other higher peroxide, other higher oxide rather, other higher oxide? We have lead oxide, manganese oxide. We also have another lead oxide here again. We have which one again? uh, Iron oxide. So how do we differentiate this peroxide from other higher oxide? Now assuming, listen o, assuming we have let's say PbO, assuming we have PbO is already here as an amphoteric oxide because it behave acidic, e also behave what? Basic. But assuming here is 2, and this 2 is already a higher oxide, and this proportion is now higher than the higher oxide, it is now referred to as what? An amphoteric, as what? As a higher oxide. So assuming this one, let's say it is the original amount is 50, then you now increase it to 60, it will be called peroxide. You now increase it to what? To 70, it's now called a what? A higher oxide. But the major thing is that peroxide is actually a member of the what? Of the higher oxide. So what is the difference between a peroxide or higher oxide and sub-oxide? Let's assume that the amount that's supposed to be there is 50, but the amount that is there is 40, which is lower than the original amount. It is called a sub-oxide. Sub-oxide. But if it is now 60, it's called a what? A higher what? Oxide. So please take note of that. There is something I would love to explain before. Okay, let's quickly rush to the uses of oxygen. Oxygen is used in respiration. We breathe in oxygen and we breathe out CO2. So without oxygen, there's no way respiration can take place. We have, it is used in oxyacetylene film, that is in the welding of metal. Welding of metal. We have steel production. We have propellant for rocket fuel. That is fuel, and we use fuel and liquid oxygen. So for fuel and liquid oxygen is used as a propellant for what? For space rocket. So please take note of that. There is that which we call allotropy. Allotropy, this is the existence of a compound to exist in two or more various forms in the same physical state. And the allotrope of oxygen is ozone. Ozone. So how do you form ozone? Ozone is formed from atmospheric oxygen by lightning flash. So when there is a lightning flash on atmospheric oxygen, the product that will be formed is called what? Ozone. And another thing again, if you are passing electric discharge through oxygen, what you are going to see is what? Is ozone. This is how you prepare ozone, and this is how ozone is formed in the atmosphere. So what is the difference between ozone and oxygen? The truth is that ozone is O2 and oxygen is what? O3. So a triatomic oxygen is referred to as what? As ozone. While the diatomic oxygen is one we know as what? As the oxygen. So what are the properties of this ozone? It is a gas. It is a pale blue gas. It has a smell of a diluted chlorine. It is a very poisonous gas, extremely poisonous. Then it is slightly soluble in water. Then ozone and oxygen, please, they have the same chemical property. They can undergo the same reaction. They can everything for ozone is the same thing for oxygen. But the difference is that ozone is more reactive than oxygen. I repeat, ozone is more reactive. The reactivity of ozone is higher than that of what? Of oxygen. So these are some of the use of ozone. It is used as a purifier. It is used as a disinfectant. It is used as a bleaching what? Agent. So that is everything about the chemistry of oxygen. If you have any question regarding what I have explained so far, or there is a part of this video you are not clear with, please feel free to drop that in the comment section. I will definitely attend to it. I have a question for you. Please, what is the major difference between, if possible, drop at least 3 difference between oxygen and ozone? I've mentioned some already in the course of my explanation. Difference between oxygen and what? And ozone. Please, if you know the answer, go to the comment section and drop that there. Examination is fast approaching already. Please share this video to your friends, to your loved ones, those who are offering CHM 111. Remember, the primary goal of doing all this is to simplify chemistry with Gido Academy. Thanks for watching. See you in the next episode.